Hey everyone, I'm Billy, and I'm here with Chandra, and welcome to Casey Jug for this October. Kind of unexpected. We were planning on doing a lightning round this month. Unfortunately, I think COVID and maybe a little bit of Zoom fatigue is kind of setting in for everyone, so we didn't quite get the signups we did, but. Luckily, yeah, Chandra reached out to me last week about doing this, and we were able to get it all together. So that's really awesome. So thanks for volunteering, Chandra. So yeah, you'll be doing learning Java Time API with Code Katas, and I think, and I'll kind of leave this all to you. But yeah, Code Katas are kind of an interesting concept to learning new technologies. But like I said, I'll leave that to you to kind of present on what that's like. But I'll go ahead and kind of get into our typical Java news. So thank you again for all of our sponsors, IBM, VMware Conju for providing the meetup fees. And again, while we're still meeting virtually for the foreseeable future, as always, thank you YRC for hosting for us. And hopefully, when we can start meeting again in person, YRC will still be able to host us for in-person meetups. And on to the Java news. I don't know if I covered this last time for our previous meetup with Venkat, but Java 15 was released last month. So that's obviously big. They're continuing the 6-month release cycle. It was actually released on September 15th. I'm pretty sure they kind of did that on purpose. Also, another kind of big thing is now OpenJDK. Before, all the source code for Java was hosted in Mercurial, which is like another source control management software, but now it's actually provided for on GitHub. So that could actually make it a little bit easier to contribute to OpenJDK if you're interested. You're not going to have to learn a new source control management system. For releases, I kind of put this together pretty quickly. I know Spring Boot 2.4 is getting pretty close to release. I think it should be released before the end of this year. I think probably next month. But a big thing, kind of along with Spring Boot 2.3, that it added a lot of features, improving when it came to Dockerization, containerization, and running in Kubernetes. And they're kind of continuing that major theme also into Spring Boot 2.4. A lot of the new changes and features are improving its compatibility in that area. Other news, I know there's some other conferences out there. At least this is a little bit of self-promotion, but JConf Peru, they're actually going to be tomorrow and Saturday. I'll actually be presenting there both days, but there's also going to be plenty of other speakers. It's going to be both in Spanish and English. My Espanol is not quite good enough yet to present in Spanish yet, but all the same, you should check it out. It should be a lot of really good speakers there, so it should be a great time. That said, if there's anything else you missed, definitely post about it here in the chat, and I'll be happy to maybe mention it here at the end. If there's something else you kind of want to have us mention to everyone, definitely just post it in there. But with all that said, I'll go ahead and kind of get it handed off to Chandra. So let me remove that. Let me add your stream. And you know what? I'll just kind of go ahead and hand it off, just because I always prefer to introduce myself at the start of the presentation. So I'll extend that benefit to you, and I'll only pop in if I see any questions.
All right, great. Thank you. So I guess you can see my screen now?
Yes, we can see your screen. Yep.
So this is beautiful Kansas City. Thank you for having me here. So let's get started. All right, we got this familiar Inception screen. Worry not, we're going to get out of this real quick. So I'm going to minimize this, and let's get started with the presentation deck. So this is going to be a presentation on Java Time API. I have about 10 or 15 slides. I want to quickly jump through those, and then we'll get into what is called the Code Kata, where we will do some hands-on exercises and see for ourselves how Java Time API works. So let's get started with the, getting the presentation out of the way so we can go into the real code stuff. Here's the deck, Java Time API. This is me. My name is Chandra. I'm a Java champion. I'm one of the representatives for BNO Mellon at the JCP Executive Committee. I've been programming in Java for a while. I'm a JUG leader myself at two Java user groups, the New York and the New Jersey Java user groups. We've just gotten a name change for NJ JavaSig, not to confuse it with NY JavaSig anymore. It's now called Garden State JUG. I blog and tweet quite ardently, and I'm a Saganist, not a Satanist. So just to let you know, there's a difference. And this is me. This explains me in short. Java and coffee. I have a prescription for coffee. So that's me. So let's get started. What are the prerequisites for today's session? You need JDK 8 or above. JDK 15 is the latest version that Billy just mentioned. You can use any version of JDK from 8 to 15. I personally use 14 for today, but JDK 15 was used to test this. So you can use any version there. You need an IDE set up with a JDK. And you need to have at least a working knowledge of Java util date and calendar, which I assume most folk in Java already have some exposure to. Great. With that, let's get started. What's the background? What are we talking about here? There are date and calendar, and we have issues with those. Java util.date is mutable only. There is no immutability associated with it, which is a huge problem. It has concurrencies issues. They're not thread safe. It has incorrect naming. It's actually not a date. It's a timestamp. It lacks any kind of convention. There are things that start with 0, things that start with 1, etc. So months begin with 0 with Java util date. And years actually begin with 1900. So if you put 0, it assumes it is 1900. It lacks fluency as well. You cannot create fluent sections of the date. For instance, you can't have durations of a date. You can't have combinations. You can't, for instance, express a credit card expiration using Java util date. You have to convert it into a string. You don't have year plus month representation. You don't have date without seconds, etc. So there are different kinds of issues that you have with date. There are more issues. The system.current time in millis, which is commonly used in a lot of code bases, has issues. It's not accurate. It can return the same value for multiple sequential calls, although seconds do increment periodically, of course. Java util date has also got some conflicts with Java SQL date, which has the same name, but is a different API. It's a date-only format, but shares the same name. There is also a Java SQL timestamp, which is even more confusing because it replicates the Java util date, but also stores nanoseconds. So it's very confusing, a mix of different kinds of API, which try to solve the same goals. These were the problems with the existing date. Let's take a look at similar problems with Java util calendar. Calendar lacks clarity. That's number one. Anyone who's used the calendar knows that it is a confusing lot of utility methods that are associated with dates. It is also quite confusing in terms of its support for time zones. It's not easy to switch time zones in a calendar. Offsets are not easily recognizable or modifiable in a calendar. Of course, it's got a lot of problems with formatting. So you can't format a calendar, use a simple date format on it, for instance. And there is a big extension hardship, which most developers may not face. But if you're writing libraries that use other calendars, for instance, if you wanted to create a Buddhist calendar or a Japanese calendar, etc., it's not very easy to create one using Java util calendar. These were some of the issues. And I don't know how many of you are familiar with the Hitchhiker's Guide to the Galaxy, but I do refer to calendar as a ravenous bug bladder beast of trawl. It is so stupid that it will eat you if it sees you, but if it can't see you, if you can't see it, it assumes it can't see you. So it's kind of a dumb setup, but it's a beast. And that is exactly what I feel with Java util calendar. And this was something I quoted back in 2000. I still hold true to this fact. But don't panic. Once again, a Hitchhiker's Guide to the reference, right? Don't panic. There are new APIs that help you solve this. There was a new proposal made, and this proposal is commonly known as the JSR 310, JSR standing for Java Specification Request. JSR 310 API was to build in a new time API into Java. I'm going to share with you 4 excerpts which are very relevant to the Code Kata, and this will probably be a wrap-up on what we want to present as theoretical material. So what was the proposal? The first proposal, and focus only on the text that is highlighted below. The rest of the text is for you to decipher later. You already have a copy or will have a copy by the end of today. It is to create an advanced and comprehensive model for date and time manipulation. That was the most important goal for creating the new API. The second important goal was to include representations of date without time, time without date, durations, and intervals, something that was missing in the Java util date. The third was to create formatting and parsing techniques, which would be simple, right? And these are to take into account the ISO 8601 standards, which are very much important when you're programming or sharing information across time zones. You want consistency, and you want to be usable across multiple languages and make it a polyglot format. And the final goal that I wanted to share with you is to have all these powerful features, but not to obscure standard use cases. This should allow for common interactivity and conversion from existing date and calendar classes, so you don't take away from somebody who's currently using them and make them go through a whole shift to get to the new API. So there were some mechanisms included that would allow you to port over from your existing API to your new one. And that was the final goal of the JSR 310. Its origins are quite simple. If any of you know Joda time, JSR 310 is heavily borrowed from or inspired from Joda time. This quote is not mine. This quote is from Stephen Colburn, who's the lead on JSR 310. It is meant to overcome shortcomings and refactor portions of the Joda time. So it's, although similar, it is not the same. There are some improvements made, and there are some things that exist in Joda time that still don't exist in datetime API. These are things that you should be aware of. We will take a look at those. There's a cheat sheet for converting from Joda time to Java time. This may no longer be relevant because a lot of new articles exist, but this was the original article written in 2014. You should definitely take a look at this. And of course, Menno Hochschild, who actually wrote another time API for Java, Time4J, actually proposed why Java time API was so much well-built compared to Joda time or his own API. The best of many libraries was taken together, and that created the Java time API. So what is the Java time API? Java time API has 4 different parts that I want to share with you, and this will end our presentation part of the session. So the first thing is containers. There are different kinds of date and time containers now available. There is something called an instant. An instant is like a numeric timestamp from Java epoch, which is January 1st, 1970, plus nanoseconds. So it goes all the way until nanoseconds. You have something called a local date, local time, and local date time, which are quite obvious, where local date just stores a date format, a date pattern, a local time that only stores the time pattern. A local date is like a calendar date in your physical calendar. A local time is like your wall clock. It does not show you the date that you're looking at. A local date time is a combination of both of the above. Then you have zone date time, offset time, and offset date time. Offset time exactly refers to having a time with a UTC plus or minus offset without a date, and offset date time combines both date and time. You don't need an offset date because it does not make a lot of relevance in this world, right? So these are the different kinds of containers that exist for dates and times. This is the first of 4 parts of what Java time API brings to the table. The next thing we want to talk about is ranges and partials. So the new time API provides for different time ranges. You can create a duration, which is usually a short time interval, like 5 minutes, for example. You can create a period, which is a longer duration. So it's in days, months, and years, whereas duration is in seconds and nanoseconds. Month is an enumeration, and it stores exactly the month and nothing else. And then you have something called month and day. Month day is basically useful when you want to, let us say, share a date of birth without the year of birth. You can actually represent that as a range now, or a partial now. A year is a partial that only contains your year and allows you to do year arithmetic on it. So you can actually find out if it's a leap year. It's not just an integer. Year month is something that you would use for, say, a credit card expiry. It's a partial. And then you have another enumeration called day of the week that actually stores the days of the week as both values, and it's enumerated strings, Sunday, Monday, Tuesday, etc. Great. Let me just get a quick. The third part of the API that we want to talk about is chronology. Chronology is a calendar system. So remember how Java util calendar had issues when it came to extension. Chronology is a factory that allows you to either fetch pre-built or create new chronologies. So you can either use ISO chronology, which is the default chronology available, or you can create your own chronologies. And chronologies, therefore, have local date time, zone date time associated with them. You could have a calendar that can exist in different regions. So does a chronology-based date calendar look like the same. And then you can also have durations within a chrono period, which could be very different from regular days and times that you have in a Gregorian calendar, for example. Era is something that stores more than one chronology. So it's a bigger range that grows across two time periods in a calendar. Similar to how you can have eras in your, the geological time period of Earth is an era, right? So you can create one or more chronologies. And the last part that I wanted to talk about is clocks. Clocks are super important and super useful, and they are mostly not covered in a lot of sessions or in a lot of articles I have looked at. Clock is a root class that provides for an exact instant and is extendable. And we'll take a look at that in our Code Katas. Our Code Katas heavily rely on clocks. There is something called a system clock. That is the default. A system clock is something that borrows from your system, your operating system, and gets you system time. A fixed clock that always returns the exact same instant anytime you query it. So it's almost like a constant. You can create a constant time and use it for, let us say, your testing. There's an offset clock, which produces an offset from whatever your underlying clock is. If your underlying clock is a system clock, it will offset a positive number of minutes, seconds, or days from whatever you mentioned there and provide you with a bigger number. The same goes with the tick clock, which is like your watch. If you have a watch that does not have a seconds hand, for example, your watch hands only move every minute. And that is exactly what a tick clock does. So you may change seconds, but your watch will still show you the same minute. And that's exactly what a tick clock does. These are different kinds of, new APIs that have been introduced. So you have containers, you have new kind of ranges and partials, you have new chronologies, and you have clocks. So we'll take a look at all of these in our Code Kata very shortly. The two other things that I wanted to talk about is usage and conventions that are followed. And these are quite important and relevant. These also show you how well the new time API is designed. This is a quick chart that I wanted to share on how our Java types map into year, month, date, hour, minute, second, etc. You'll notice that the green slots that you have represent what features each container can carry. For instance, an instant is exactly a second with nanos. A local date only carries year, month, and date. A local time carries hour, minute, second with nano, etc. The only two distincting factors over here are for month and day of week, which are enumerations. They are enums, so they also hold numerical values with them. Other than that, the rest of them only hold dates and times, hours, minutes, etc. There are examples on how these are useful as well. So each of these examples, an instant represents an exact instant. You have a date, a time, etc. The only challenges that you will have is in a month day, which has an extra hyphen at the beginning. That is something that you should be aware of. So if you're formatting a month day, just be aware that it has a starting hyphen that you do need to get rid of. I've still not been able to find out why this is the case, but this is how it exists as of today. The other convention that I wanted to share before we go into the Code Kata is the method signatures. Methods are prefixed with some of the first column strings. So if you see a method that begins with an off, it typically is a static method, and it is used to convert from one to another. So it basically does some sort of a build of a timestamp or a container. A from derives from something else and builds a container. A parse actually formats and takes out a string reads from a string and converts it into a container. And these three are static methods. Then you have instance methods on the containers themselves, such as format, get, is, with, etc., which perform different activities. For instance, a format allows you to convert a container into a readable string. A get method gets you a part or full portion of the time or date that you are looking at. There is, which is mostly used for querying, etc., and so on and so forth. I'm not going to go through every single method name over here, but these methods do exist. And this presentation is shared. You will momentarily get it as soon as we step into the Code Kata. The last slide that I wanted to share about is with JDBC support. JDBC is still a very relevant part of the equation. I know we talked about Java SQL timestamp, Java SQL date as being hurdles in understanding Java util date and Java util calendar. There is now parity between the Java 8 time API and what is useful for the SQL parts of it. So date is represented as local date and so on and so forth. This table represents all the values that are interconvertible between, let us say, an ANSI SQL versus Java 8 and above time API. So that's it. I think I wrapped up my workshop. I didn't want to spend too much time on this. Before we get set up, are there any questions about anything that I just shared?
Yeah. So Ilmer asked a question. He was wanting to know, are all date and time classes immutable?
So with the new API, yes.
And is that the new API part of Java 8 correct, or is that something newer than Java 8?
So Java 8 onwards, everything is immutable.
All right, cool.
Okay, thank you, Hilmer. That's a great question. Okay, so we are going to get started with the Code Kata. So let me just open up my Sublime text so you can see where it is located. Here is the GitHub link. This is my GitHub link, Guntur, and under Guntur, you have Java Katas as a repository. Now, if you check out the entire repository, you don't just get date time, you get handles, lambdas, and optional as well. And if you like the repo, please do hit the star button. I would appreciate more stars. So thank you for that in advance. And if you have any kind of, feature requests or any questions or concerns about what exists in this Code Kata, please feel free to ask. A quick overview of what a Code Kata is. A Code Kata, let me just expand this, is basically a mechanism of teaching. If you watch the Karate Kid, that is exactly what a Code Kata is. It is a means of where you repeatedly do the same actions, and these build your muscle memory. So what we are attempting to do here is to take some code that is broken and fix it. Once it's fixed, we run everything. We just trash that, again download the code, and again keep repeating it, so on and so forth, until we build a muscle memory of how to do certain things. We're going to do this with Java Datetime API today. So let's get started. What is in the repo? You have Java handles, Java datetime, optional, and lambdas. Today, we're only looking at Java datetime. So let me just open up this is how I check the code out. I basically go HTTPS and I copy my HTTPS link. You could choose to use the CLI. You could choose to use the Git SSH, whatever mechanism, and Git clone. Here is my Git clone. I've just performed the Git clone before the session started, and I checked out the code. So if I were to just look for my code, I should have Java Katas here. And under Java Katas, I should be able to locate the Java Time API. So there is your datetime API. And that's what we will look at. So the way we set this code up is we go to IntelliJ and we open a new project. I checked it out to the temp directory. So I'm going to go into my temp directory, Java Katas, Java datetime, and I will open the pom.xml file. Once I open the POM XML file, it asks me if I wanted to open it as a file or project. I obviously want to open it as a project. You definitely cannot see the logo here, but if you wanted to see the logo and how cool it looks like, you actually go to the datetime and you will find the logo there. IntelliJ currently, for some reason, does not render the logo, but it is the same code as you see in your code base. The deck that I just shared is also located right underneath it. You can feel free to open the PDF file from there, should you choose to refer to it. Now, you have the source here, and I just want you to walk you through the source tree, which I can do in the browser as well. So the way this is set up is there is a POM XML file, there is a README file. You just saw the README file. We'll go through the POM XML file in a bit. And under source, you have a test folder, a main folder, and a solutions folder, or directory. I'm sorry, I keep calling it folder. The test directory is where we will focus for the Code Katas. The main directory is something I'll show you real quick. It has 2 or 3 helper classes that we use. And the solutions is parity with test. Every exercise you have under the test has an equivalent solution under the solutions directory. These are the different tests that we'll look at today. And the parity between the test and the solution are also linked. So if you wanted immediate access, you could just click on this and see it in GitHub itself. So that's how the Code Kata is set up. Let's quickly go through the exercises. Let me just expand this part of my screen real quick. So you have source main and source solutions and source test. These are the 3 parts of the API we will look at. So great, let's open the source main real quick. And before I do that, let me increase my font so it's more visible. So I go to my editor, code editing, general. Okay, hopefully this took. Great. Billy, can you let me know if the code is visible? Should I increase the font?
It's visible. You may want to expand it just a couple more times. Yeah, that should be good. Yeah, that should be big enough. Yep.
Okay, great. I'm going to keep remembering to do that, but please do interrupt me if you see me forgetting to increase the font size. Let me just take care of that right away, in fact. So let's go to my color scheme. Okay, so yeah, so this is the first class that I wanted to show you. I don't know, unfortunately I don't have visual cues here. This is what I would ask if we were doing this in person, but this code base uses JUnit 5. I don't know how many of you are familiar with JUnit 5, but most of the code kata, in fact, every code kata that we have out here in Java Katas uses JUnit 5. And this is also a good reference for you to understand that. The first class that I wanted to share with you is a display names that is used to render names of your tests. So basically, instead of printing out class and method names, it uses some code to determine what to print out when you run your tests. And we'll take a look at it as we go along. Here I have modified what the class name should be displayed as. I've modified what the nested class should look like and a method should look like. And I've camel cased some text to make it look more pretty when we read it. And we'll take a look at that in a minute. Another thing that I wanted to share with you is JUnit brings about its own assertions. So you can actually assert code to look equals or assert true, assert false, assert not null, etc. One of the assertions that I required for this test was to create an assert almost equals. Now this does not come by default. So I created an assertion package or an assertion class that does assert almost equals. It takes two values and compares that they are equal within a given tolerance. So if I subtract the first one from the second and do an absolute on it, its value should be less than the tolerance. And I then declare them as almost equal. And this is something we will use in a first or second code katas. It's not very important, but I just wanted to let you know how you can extend assertions and write your own assertions. And we'll take a look at it in a few minutes. I'm going to ignore the solutions package, but I just wanted to show you how the JUnit naming conventions work. So if I were to take the first test and just run it, right, I'm just going to run and I will show you the output of this run. Okay, great. So let's just expand this and you will notice that instead of class names and method names, it actually prints the thing that I wanted to print. It prints out a display name. It prints out method names the way I wanted them printed out, rather than printing out something that a typical JUnit would. So I've actually expanded upon how JUnit would format the output results. That's the reason why this datetime display name exists. And we'll also take a look at lenient assert in a little bit. Great, I'm going to close out of this. And let's go into our first code kata here. Great, so we step into the test module. And under the test module, we have 6 tests. We're going to attempt to cover a few of these. We have about an hour, so I'm going to try and attempt to cover as many of these as is possible today. Great. To begin with, how does this test look like? So the first, you'll actually notice that the test describes what we're attempting to do here. We're trying to show interoperability between Java util date and the newer Java time instant. We use instant, we use date, and we use lenient assert that we just talked about. Here I have a display name generator, which says that, hey, when you run this test, use whatever the display name generator shows for the class name and for method names. On top of it, I have actually overridden what the display name generator does, just to prove my point, is that not only can I use what is coded, I can also override it with whatever display name I wanted. So instead of it producing something like kata1 instant date time interop, it actually reads instant and date interoperability over here. So that's something you can do. You can control how your results look like. I create a classic date first, which is nothing but your Java util date. It's declared here. I use a simple date formatter. The simple date formatter is something many of you may be familiar with. I've used an ISO 8601 timestamp signature here. And in my setup, which is run before every test, I'm creating a new date. Right, so that is something simple and useful. We are going to see how this works out in a bit. What does my first test look like? My first test reads @test, which is the JUnit annotation for me to run this as a part of my JUnit. It has a tag of to do. We'll cover this tag in a little bit. For now, understand that this means that you need to solve this exercise. And it says order 1. If you notice, I've set up a test method order on line 31. that tells me that my tests need to be executed in a certain order. Now, if you're writing production code, I would advise you strongly not to order your tests. If you order your tests, you will eventually end up bringing in some dependency of one test on another, which defeats the purpose of unit tests. But in a code kata, it makes a lot of sense for me to run tests in a sequence so as to prove a point of what we're trying to teach sequentially. So ordering test methods is a great benefit when it comes to code katas, but is extremely horrible if you're running it in a production code base. So please don't attempt to do it in your applications. Do not order your tests. But for code katas, if you write some, I heavily recommend ordering your tests. So they look much more sequential when you run them. Great. So what are we doing here? Here I'm verifying instant and date to have the same epoch milliseconds. What is epoch? In Java, epoch means January 1st, 1970. So we're looking at the number of milliseconds in an instant and comparing it to a date and ensuring that they both match. So if I were to run this test now, I create an instant.now, but in my setup, I created a classic date, new date. I'm assuming they were created at slightly different timestamps, and therefore they should not be the same. The milliseconds should be different. That is my hope. So this test should technically fail right now. Let's run this. And as noticed, it does fail. It tells you that it is actually null. Why is it null? We then go take a look. It says to do, replace the null below with to get milliseconds from the epoch and use them. Okay, let's go fix this. If I were to go here and change this from null to say instant, and there is a hint here that tells me to do instant.to epoch milli. Okay, let's try that, to epoch milli. Great, this should now work. Let's run this again. And you notice I now have another error. And if you notice, the error is much more nicer. It says there is a 2 millisecond difference between the expected and actual. Where did I go wrong? I go back and take a look at what I did. So it says I created an instant.now and a new date a few milliseconds before that. How do I solve it? Maybe instant.now is the wrong thing to do. Maybe I can do something like classic date and to instant. Okay, let's try using the to instant method, see what it does. And if I were to run this, my code now works. So what did I achieve? Here is a parity between the classic date and its equivalent instant. So I can actually create the new Java 8 container of instant from an existing Java util date. And there is a conversion using to instant. Now, one of the prefixes we talked about was to, which is an instance prefix, instance method prefix that converts from one to another. So great, we have now tested and passed the first test. Let's move on to the next test. What are we doing in our next test? Here I have an instant and date, and I'm trying to verify they both have this almost the same epoch seconds. Okay, and why is it almost? It is because I may have accidentally truncated something while I was doing the math here. Right, I have some math going on. I create an instant from my classic date, and then I take my classic date and I'm getting the time out of it, which gets me the seconds, milliseconds, and I'm dividing them by 1,000 to get the seconds. So I may have some truncation errors. It may be off by 1 or 2. So what am I doing? I am setting the tolerance to 1 and doing my lenient assert of assert almost equals. I take the classic date in seconds, get time, and I have a null here, which means something is going to break as soon as I run it. So let's run this. When I run this code, you notice that they don't match because it was null. So let's go fix this code. What do we fix? We now somehow need to get something from the instant in order to verify this. So let's do instant dot. What API can I use? It says get epoch second is a possible API I could check. And IntelliJ was smart enough to show me that API as well. So now I have set the instant.get epoch second, which is the very similar result as what classic date.get time divided by 1,000 should get me. So I should get the seconds from epoch from a get epoch second. Let's run this code and verify that. Great. So the first test proved that we have parity between instant and date. The second one proves that I can get individual elements such as seconds out of a date as well as out of an instant. There are many times folk have written similar methods to calculate seconds. They do classic date.get time divided by 1,000. Now that was never accurate. With instant, you get more accurate results. So we had to add a tolerance over here. What we've now shown is that instance is more accurate and provides for more humane APIs for you to access what was not available in date. What does my third API look like? Here, I'm trying to verify that instant has nanoseconds. We all know that date did not. That is something that we already knew as a shortcoming of a date, but instance should have nanoseconds. I have an instant that I created of now, right? And I'm asserting that it should have at least a nanosecond. Now, it's not very easy to prove that there is a nanosecond, right? Because what if I run this code at the exact time when the nanoseconds was 0? So I set the value to be greater than -2 to verify that there exists something like nanoseconds there. So let's quickly check that code. So when I run this code, it actually fails. And why does it fail? It says -2 is not a valid value. In fact, you should get something over here. And what do we get? How do I get nanoseconds from an instant? I go instant dot. There should be a method for me to get nanoseconds. And looks like there is a method called getNano. And if I were to run the code, I should definitely be able to assert that this is true. And there you go. You have nanoseconds in an instant, and we have proved that it is available through an API called getNano. Now, we've looked at some of the APIs for instant. Let's wrap things up. I think there are 2 more tests in this. So let's wrap those 2 tests and go into the more interesting clocks. What is the next test? In the next test, I have classic date formatter. I'm setting the time zone, and this is how you used to set time zones in the past. You had to do a simple date format and set its time zone to UTC, and that's when you could actually render results in a UTC format. With an instant, what do we do? So with an instant, I first convert the classic date into an instant. We saw this in the first test, and now I want to print it out. What is the best way to do it? There is an instant.toString method. Let's use that. Okay, so an instance.toString method should actually get me the classic ISO 8601 formatter, which means it has simplified things for me where I don't have to create a formatter if I just wanted an ISO 8601 representation. Let's verify that. And once again, the test pass. We show that instant has humane API to format a date in the default format for me without me specifying anything. If you were to do this on a date, you get a java.util.ldate followed by a parentheses followed by an object hash. Instant actually returns a formatted date string for you. So this is much more better than what we used to get with the classic date. Another good reason for you to switch to the Java 8 API. The last thing we wanted to check in this test is to verify instant date interoperability. So I should be able to convert from an instant to a date and from a date to an instant. How do we do this? We've already seen how to convert from a date to an instant. You can do a date.toInstant, and you get the API back as an instant. And we can verify that, and we've already done this, so we're not going to repeat that test. However, if you have an instant, how can you convert it into a date? And here is an API that could help us. In date, you have a from. And from is a static API, if you remember. Let me just go back to the code and verify that I'm not telling you stuff that was not shared. From is a static method. And let's go take a look at how date.from works. So if I were to do date.from and I pass it an instant, I should be able to verify that the another date matches the same thing as an instant, which matches the same thing as a classic date. Let's run this test. Awesome. So we've passed all these tests. So before we move ahead, I just wanted to take a quick time out and ask if anyone has questions or if there are any concerns about the setup of the code, so we don't have too many hurdles as we go along.
So there was one question. Nihat was asking, what Java version are you using? I believe this is anything 8 or later.
Correct.
Okay.
In this one case, I'm using Java 14, I believe, but you should be able to use anything from 8 through 14.
Okay, great. Thank you.
So let's quickly verify that. I am using 14.
Okay, cool. Thank you.
Thank you. Unless there are any other questions with the setup, let me know. Please keep me posted. I would very much like you to code along. But if you can't, please do feel free to reach out to me after as well. My Twitter handle is @cguntur. Please feel free to connect with me afterwards. Great. So this was test one. Test one was probably not so exciting. And then I'll be very honest, it's not something I show off as the most exciting test. Test two is probably extremely relevant, something many people don't know about. So I want you to pay more attention to test two. Test one was simple. Any Google search would have given you what we learned in test one. Test two brings about Java time clock. Clock is something that is an unsung hero most people don't know about. You should know about clock. There's not one but 4 kinds of clocks. We talked about it in the presentation part. You have a system clock, you have a fixed clock, you have a offset clock, and a tick clock. I'm only going to cover 2 clocks here, but I want you to run the other 2 clocks yourself. There are 4 examples here. I want you to run all 4 of them. So in your code, you will notice that there are system clock test, fixed clock test, offset clock test, and tick clock test. I'm only going to do system and fixed clock. If time permits, we're going to go back into doing the other 2 clocks as well. So here is a test for the system clock. And what is a system clock? It just represents system time. So what am I doing first? In Java 8, the best way to know your time zone offset is on line 43 and 44. This is again a frequently asked question. Stack Overflow probably has this repeated 10 or 15 times. How do I get the offset, my current offset, using Java 8 time API? The way you do it is you first create an instance of an offset date time. We'll look at the Code Kata for this later, but this is something that I needed to get off the way because we need to use the zone offset. So offset date time is something you create an instance of. .now is a static method available on all containers that return a current time matching that particular container. So if you do local time.now, you get the current time. You do local date.now, you get today's date. And you do local date time.now, you get today's date and time. If you do offset, you get today's date and time along with the offset hours. So you get the zone offset alongside it. So if I were to do it sitting here in New Jersey, I am going to get today's date, and I will know that the offset is actually GMT -4. And that is something very useful. And we will use that momentarily. So what are we doing here? So we first created an instance of offset date time. And from there, we actually created a zone offset by fetching it from the offset date time. So if I were to just put in a system out println here, so we can see how offset date time looks like. Let's do that. All right. So before we run this, we'll also take a look at what the offset date time looks like. So great. Now to create a system clock, what are we doing? We have a date that we want to achieve, that is 2005-05-05. I'm sorry, this method is not, this is not the right comment here, but we'll get to the right comment in a bit. We create a local time with whatever system clock we create. And on the, let me just get rid of this message. This message is actually incorrect. You don't need this here. You only need the last line. Right. We'll show you how to do that. You create a local time without any clock. And from there, you create a local time with a clock. So you create 2 clocks. You create a clock from a local time. You create a local time without a clock. And you get the seconds from both of those, and you compare the seconds. And they should match because you're using the system clock in both cases. So we're just verifying that the system clock returns me the same time as not using a clock does. Let's start. So the first thing we need to do is we have clocks. And funnily enough, IntelliJ just gives me the method I'm looking for. It says clock.systemDefaultZone, so I can actually get the current time zone's clock. Great, we got that. And then from there, I can create a local time without a clock. So here we have it. We have a local date time of now. This is just going to return my current date and time. And then I have a local date time with clock. Now, this actually shows a local date time off, and we don't need this. And the to-do tells me to replace the current off method signature. So let's get rid of this. And it says use a local time now and pass it a clock. So let's pass it a clock. I have a system clock. I'm going to use that. Great. So I have a local date time that is created without a clock, and I have a local date time that is created with a clock, and I'm using the system default zone clock here. So now I get the seconds from both, and I'm verifying that the seconds are almost equal. Now, why is it almost equal? Because there are 2 different methods on 2 different lines time may have elapsed between my first call and second call. So the seconds may or may not be the same. Maybe a second tick passed from when I created line 51 to when I reached line 56. So I'm doing an almost equals with the tolerance of 1 second. More than 1 second could not have elapsed between the two calls anyways. So let's run this test and see if it works. Great. So what we verified is that the offset date time looks like this. I get my current time. This is 1900, which is 7 p.m. Very appropriately. And at 7 p.m., my offset is -4, GMT -4. So that's what my offset time brings me. And my test pass, which tells me that my system clock or not using any clock should get me the exact same result. This is useful if you're trying to verify a system clock of a different time zone. Although I use the system default time zone, you could use other system clocks as well from another time zone. That's possible, and we'll take a look at it if time permits. But for now, we're going to move on and take a look at the next test. Fixed clock is probably the most useful thing you will find when you run unit tests. You want to test with an exact instant all the time, so as to not depend upon any features that are relevant to current time. So for instance, in this case, I don't know how many of you are fans of 2001 Space Odyssey. Hal the computer was born on January 12th, 1999. And we're going to use Hal's birthday for this test. So first thing we do, we create an offset. We're going to ignore that offset for now. We've already talked about why we need to create an offset. It gives me the number, the difference from GMT or UTC to where I am currently sharing this demo from. I create an instance of the UTC HAL birthday, which is 1999, January 12th. There's an ISO 8601 format, and HAL was created in California, so Pacific Standard Time, which is GMT -8. And that is what we've specified here. So I'm letting the system know that HAL's birthday was on January 12th at midnight, which was 8 hours after GMT, right? So that's what we declared over here as the instant. And I have to create a UTC clock for HAL, which I created as a clock.system default zone. But I'm sitting in New York, and that's not right. So this will actually give me wrong results. And my to-do says, replace the system clock with a fixed clock. We'll take a look at that in a minute. The further to-dos actually go, replace the system clock with the fixed clock instance when I create my local date, and I create my local date time, and I verify that I can pull the local date and local date time from Hal's birthday and not today. So that's what I'm trying to do over here. So let's take a quick look. What do we do? First thing we do is we create the clock with the system default time zone. And when I use my local birthday clock, this to-do is fixed. So let's go to this to-do. Instead of using a system, I will use the fixed clock I just create, which is UTC clock for HAL. That's the clock I created. And the birthday time for HAL, where I use a local date time, and I change this to the UTC clock for HAL. So I created a fixed clock. I didn't create a fixed clock, sorry. I create a fixed clock, and this fixed clock needs a time zone. Where is my time zone? My time zone is from the offset that I just created. So let's create a zone. I could create an off offset, or I could do a UTC offset. Let's just try the zone ID UTC for now. Zone ID, I don't know what's happening. Off. Thank you. That was missing earlier. Should work. I don't know why it's giving me an error, but that should work. Okay. I'm sorry, I didn't pass the instant here. UTC HAL birthday. Come on. Okay. So here's what I was missing. I have to pass it the instant that I'm creating the fixed clock for, so I know what time I want to show. So here is the instant, but I'm passing it in UTC. I'm verifying that anytime I ask for local date, if I pass this clock, I should always end up getting the exact same 1999 January 12th. Although it is today, which is 2020, October the 22nd, I should always get 1999 by passing it my clock. So my clock always returns a fixed instant in UTC time. Now, if I were to run these assertions, the year should be 1999. The hour of day should be 8 o'clock and not 00 because it is UTC time. I set the zone ID of UTC. And I should verify that my millisecond is 1. So I have 1 millisecond here, and I'm verifying that I'm getting 1 millisecond there as well. So let's just verify this fixed clock real quick. And you notice that my fixed clock returns 1999 January 12th all the time. Now, why is this useful? This is extremely useful because if you were to write tests that involve local date and local time, passing it a clock will allow you to always control your results. So you can test for functionality rather than test for what date or time you are currently passing, what time zone you are in. Those are all no longer your worry because you have set a fixed clock. Now, you could be anywhere in the world, run your code, and your test will always pass because it is the right way to test your local date and local time based code. And that is something very useful and a good takeaway for you to carry forward. Always use clocks when you write your unit tests. Try to use fixed clocks as much as possible when you write your unit tests because they are guaranteed to give you results that you expect, success or failure. Right? If you want to write negative tests, even then a fixed clock is extremely important and useful. The other two tests that I just will walk you through is an offset clock based test. Why is it important? So rather than show you the current time, say right now it is 7:06 p.m. in Eastern time, I could actually set it to show me Kansas City time by setting an offset of +1, right? Or -1. And when I do that, I can actually keep generating a durational clock, which will increase in time. It is very similar to a fixed clock. I pass it whatever instant I have, and I can pass it another clock if I needed to, and the duration I wanted to add to the existing clock. It's always a positive duration. So here I can put in a duration of 1 hour, and I can set a chrono unit of chrono unit 1 hour, and it would increment the clock by 1 anywhere I am in the world. And that is quite important and useful. The fourth clock is called a tick clock, and a tick clock is basically how your watch ticks. So if you have a second hand, for example, it ticks every 1 second, and there is no movement for that 1 second. So you could have a few milliseconds pass by, but nothing changes on your physical clock. The same thing happens with the tick clock. If I were to set my tick to say 30 seconds, I could move in increments of, let us say, 5 seconds, 10 seconds, and so on and so forth until it is 30 seconds. My watch remains exactly the same time it was. And that's what we're trying to prove here, is that when I increment by, let us say, 10 seconds in the first case, here it is 0, so 0 seconds, 10 seconds, and then there is a 20-second time period and a 30-second time period. I'm verifying that for the first 30 seconds, the instant is less than 30 seconds, so there is no change in time. So you've controlled how often your clock changes. So when you see a scoreboard or any kind of indicator where there's a time change, if you're looking at a game, you look at the number of seconds remaining on the clock, they don't change until the second increments by 1. And that's what we're doing with a tick clock here. So at the end of 30 seconds, you'll notice that the times no longer match because now the second hand has moved. Right? You could do this with seconds, minutes, and hours, so on and so forth. You cannot attempt to do it with years because you should not be able to tick that long. Usually ticks are until hours, but days are also allowed. Now, you have API for all this, and I just wanted to spend a minute on the API so you understand this code a bit more better. Here is your clock API. There's a lot of wealthy Java doc information that you should absolutely read. But what is more important is all the methods that we saw as clock.systemDefaultZone, clock.offset, clock.fixit, clock.tick, they're all resulting in you getting instances of the clock. And here is your system clock instance, for example. It's an implementation that returns the latest time from system current time milliseconds. We saw this. There is fixed clock, which returns an exact same time every time you look at it. There is an offset clock that returns an offset to the underlying clock you use. So it can operate on top of another clock. So you can have a clock within a clock. And then there is a tick clock. Now, there's a problem with tick clock. Their Java doc is wrong. Their Java doc, unfortunately, still points to an offset clock. There's something that they need to fix. But a tick clock basically is like a clock on a watch or a wall clock. So ignore this text because this text is wrong. This is in Java code, so obviously I can't go change that. But yeah, this is something that needs to be changed. There's something you should ignore for now, but read the tick clock implementation if you wanted to understand how it works. Clocks are important. Make sure you use clocks when you test. That's a message I would like you to take forward. Once again, before we go into the next test, I'm going to take a quick break, ask if any of you have any questions.
So Kendrick does have a question. He said on line 88 in Code Kata 2, it's apparently having an issue when it's trying to parse date time. It might be a bit difficult. It might be something you may want to look at after this, just because me reading out the text he's having might be a bit difficult to solve, but just pointing that out for maybe something to check after you're done.
Absolutely will.
Okay.
Thank you for letting me know.
Yeah.
Kendrick, please do connect with me or at the end of this kata, so I'll probably have some more time. We can catch up and take a look at that.
Yep.
Hopefully that's not causing you to stop other tests, but let's move forward. Now, what did we cover so far? We covered that we have instant and date interoperability. We saw the importance of clocks, and these are vital and very important, useful things that you should always remember. Now, this next test focuses on a few containers: local date, local date time, and zone date time. And we will heavily use clocks here. So that is something I want you to understand. We also create a clock instance in the setup. So you have a familiarity with how clocks work and what is the typical way in which clocks are used. So for this example, I'm a big fan of Terminator. I don't know how many of you are. The original Terminator Judgment Day that was declared in Terminator 2, not 1, by the way, was August 29th, 1997 at 2:14 a.m. to be precise, in New York and Washington, D.C. So we're going to use that time throughout this code kata to understand how a fixed clock works. So here I have an instant, and I have created that very instance, 1997, August 29th, 6:14:30 Z, which is UTC time, which then translates to 2:14 a.m. Eastern time. Now, this is GMT -4. We make an assumption of GMT -4 as a standard for all these tests. So you may be sitting in Kansas or in California. You will all run this test and look exactly the same to all of you. And that's what we've done here, right? This is a point I'm trying to make with using clocks. I created a fixed clock of the instance that I have, that is 1997-08-29, in the time zone that I want, that is GMT -4, because that's where Event Horizon 4 Judgment Day happened. It happened in Eastern Daylight Time, which is GMT -4 in August, and that's what we use. And that's what anyone else in the world running this test should use. So no matter where you are, this test should pass. Great. Now, what is our first test? The to-do tells you that there is March is a month 2 in the old API. I don't know if you remember, but in calendar, when you do month of 0, it gives you January. And when you do month of 2, it does March. That's extremely annoying and hard. People can't understand why it is so, because years, months, and dates do not begin with 0. Although coding does that, real life doesn't. So if I were to declare St. Patrick's Day with my new API, what should I do? Here's St. Patrick's Day in 2015. And we want to fix it to use the date of 2015-03-17 and try to use integers for months, years, and dates. Let's do this. It says local date.now. Obviously, that is wrong. And if I were to run this test, it should fail. Hopefully, it fails. Great. It does fail because it says the date is 2020, not 2015, October 22nd. So let's go fix this. Here is a method that you will find most commonly using when you create dates from integers. There is an off method. It's a static method. And the signature is going to look like 2015, comma 3, not 2. Months are now exactly the same way they are numbered on a calendar. And you have 17, which is the day you want to run for. So if I were to run this code now, this should pass. Hopefully, I'm crossing my fingers. And there you go. So now we can see that it is easier to create a date. They translate to exactly how you write dates. You don't have to do that conversion of month -1 when you create a date using calendar API, right? So that is something that is quite useful and important, and it's also very humane to use the exact same structures as you see outside in the real world in your coding practices as well. What is the second date? The second test is very similar to the first, but instead of those confusing numbers that we use, it is asking us to use enums, and there is a month enum. So instead of us using 3, let's use a month enum, which is much more non-confusing, right? Anywhere you are in the world, it's year, month enum, and date. You cannot go wrong with it. So let's try that now. So what do we have here? We have Hal's birthday, which is 1999, January 12th. Hal being my favorite computer of all times. So let's go change his birthday to be exact. And before we do that, let's run the code to make sure that we're originally failing and we want to succeed when we make the change. Obviously, we are failing right now. The year is not the same. So let's go fix that. So we do local time off and we pass it 1999, the year of Hal's birth, and the month of his birth would actually be month dot March. So I don't need to know if it's 2 or 3. I just use month dot March and it should work. And obviously, I'm sorry, not March. That would be wrong. Our test would fail. It would be January. And when was Hal born? On the 12th. And here we have our new code base where we say local date of year, month enumeration, and date. Let's run this code now. And we pass. So we've now proved that we can actually not only use numerical values for month, but make it non-confusing by using enumerated values instead. And this brings about a lot of benefit because now you don't have to worry about what part of the world treats this as month 0, what part of the world treats this as month 1. What if they have a different calendar? Month.January is the same everywhere, right? And that's easier to identify. And when you create your own chronologies, you will create your own enumerations for what you represent as months. So this allows for extensibility when you use the newer APIs. So once again, this is a very good reason for you to switch to the newer APIs. Lesser confusion compared to date and calendar. Great. What's our next API look like? Verify local date using a clock. So here we are using the power of a clock. We've already seen this, but we want to test it out on why clocks are important. Code Katas, you will find things get repeated, and there's a good reason to repeat it. It builds your muscle memory for you. So what are we doing here? We know the original judgment date, and we're creating a clock of now. And we are expecting its year to be 1997, month to be August, and month value to be 8. Now this is going to fail, obviously, because local date time of now, or local date of now, should result in 2020 October 22nd. So let's run this real quick and verify that we fail. Great. Now that we fail, let's go fix this. Instead of just a now, which is empty, we have to pass it a system clock. We created a system clock in our setup. We call it the Terminator Original Judgment Day Clock. And so let's go put that in here. And that's the only change I need to make. So I have shifted from using a system clock to a fixed clock. My time always will return 1997 on the date the judgment date happened, which is 2:14 a.m. Eastern time. And let's run this now. And lo and behold, we have verified that anytime I run this code, I am going to get a value of the judgment day's time rather than today's time, although I passed it a local date of now. A clock can control which time I am being presented with. And that is something I want you to take away. That was verifying how local date can be established using a clock. Now, the next few examples are extremely similar, and we'll go through them very quickly. I don't want to spend a lot of time because they'll be pretty much repetitious to what we've already done. What are we doing here? We're creating a local time, and we're creating a local time of 7:52. How do we do that? It's not 7:52 yet. It's only 7:18. So how do we do that? What we do is instead of now, we can pass an off and pass it 7:52, 0. Right? I could do this, or I could get it to 0. Right? So I can either pass it an hour and minute or an hour, minute, and second. So let's verify that the actual time that is printed from a local time, you can just do a toString and it should print 0752. Let's verify that. And lo and behold, it works. So this is how you can create a local time by passing it integers. Let's take a look at how you can do local time using a clock. Now, we're using a UTC clock here. So that's a little catch. What are we doing here? We set the time in GMT and we're using a UTC clock, right? How do we do that? We actually set the GMT offset to -4. I don't know if you recollect in our setup. Let's quickly go to our setup. And notice that we actually set a zone ID of GMT -4, so the time representation would be 2 and not 6. Let's go back to our method where we do the local time using a clock. And now, instead of a now, what should I pass here? Can anyone tell me? Billy, can you monitor if someone is typing in a response?
No, there's also about like a 30 or so second delay. So,
okay. All right. Oh, my apologies.
Yeah, no problem.
So if I were to use the clock here, should this work? I've set the time as 2:14. I've created a local time, and my GMT offset was set. So let's verify that this works. And you will notice that it is successful. So although my time was set in GMT, I set a GMT offset for the clock. And when I expose a local time from that clock, I am getting the value in my time zone that I set up there, which is GMT -4. So even though you're sitting in Kansas City, you will be able to see 2 a.m. because it's not using your system clock. So you are better verifiers of the system than I would sitting in New York, where my time zone matches whatever GMT offset I set. So this is to prove that your clocks work against local time by supplying you the value of the local time you declare rather than the local time on your own local computer. And that is one of the benefits you get by using clocks. So use clocks as much as you can. Clocks are your arsenal, they're your tool. You should use clocks as heavily as you can. Great. I think there are 2 more tests here that I would like to cover. The first test is verify local date time using integers. Obviously, this is very similar to what we have done before, and we are using integers here. So I can go 2005. What is my date? 5555. Okay, that should be easy. 5, 5, 5, 5, 5. Should do it, right? Year, month, date, hour, minute, second. Okay, so we've created a date here. And why is it complaining? Because I used a now instead of an off. And lo and behold, we created year, month, days of month, hour, minute, second, local date, time. And when I run this test, I'm able to verify that my month value is 5, my minute is 5, and my second is 5. So let's run this test. Great, that works. That was easy. And once again, you can do local date time with clock. So let's run this clock. And instead of a now, I can pass it the terminator judgment day clock. And what does the assertion expect? It expects my month value to be 8, which is August, which is fine. My hour to be 2 because I'm using a local date time, and my minute to be 14. So let's run this test because we made this change. And great. So we've seen another example where local date time can use a clock. Now it's getting repetition. So I'm not going to keep doing that. You can also do zone date times, right? And there is very similar in zone date times. There's a little bit of a challenge here. There's something that you need to know with zone date time. A zone date time is somewhat different from an offset date time. So in a zone date time, you get a zone offset applied to it. So that's a subtle difference between an offset date time and a zone date time. It includes a time zone with it. So if you want, let's just print this out real quick to see how the zone date time looks like. Let's run this. So I want to print my zone date time, which is and I think it is all date time 5. Okay, so we are printing out the zone date time. We can see how it looks like. And my zone offset is set to -5, which is probably Kansas City right now. And my offset is at 1 hour plus. So I'm actually offsetting it to GMT +1 or UTC +1. And that's what I've done with my zone ID. So I've created a new zone ID. And when I create my zone date time for GMT +1 date time, at this time, I need to somehow pass it the zone ID and say, hey, convert it into this zone ID for me. So how do I convert a time from one time zone to another? And this is an example doing that. So I have a now, and this now is going to print the current time in that zone, and that's not going to work. So my tests are going to probably fail because of this. So how do I fix that? The way to fix it is there is an API in zone date time that uses the same zone, same instant of a given zone ID. So show me this time in this zone for the same instant is what we are doing here. So how do we do this? So my zone date time that I already have is all date time 05. So let's copy this, and we can do something like all date time of 5s dot with same time zone instant of the zone ID we created, which is GMT plus 1 zone ID. So instead of using a now, I have created a zone date time, and from that I'm creating another zone date time in another zone with the same instant. And so when I run this, I should be able to check that the total seconds is 3600, which is 5 minutes. That is 5. And it should be an 11 hours, not 5 hours, because there's a 6-hour difference between GMT minus 5 and GMT plus 1. So I should see that 6-hour differential when I run a get hour method for my new date. And let's run this real quick, verify that we have that output. And it passes. So what have we done? We have taken a time in a current time zone of -5, and we've converted it into a time for a different time zone, which is 6 hours ahead, and we are proving that it works. And how do we do that? We take the zone date time, and with the zone and for the same time, same instant, we are passing it the zone ID, and therefore are able to get the time in that new zone ID region. And that's how you can convert times to, let us say, different GMTs or UTCs, and that's how it works. There's a conversion mechanism. Once again, you can do this with a clock. That's going to get monotonous. So instead of a now, you could pass it the terminated judgment day clock that we created. And obviously, this should work. So I don't want to spend too much time on this. So before we move ahead, any questions on usages of local date, local time, zone date time, offset date, offset time?
No recent questions since the last time you asked.
Okay, great. So we're going to jump into the next topic, which is ranges and partials. And these are quite interesting by themselves because they offer you ways in which you can chunk your date to get portions or retrieve portions of it. Let's take a quick look. And there are very few tests here. I think there are 4 or 5 tests, so we don't have to spend a lot of time with this. But here is how the periods look like, right? First, we are creating a clock. Once again, this is the same clock we used in the past. This is the terminator judgment day clock set at 6:14 UTC time, which is 2:14 New York time, where judgment day happened. The first thing we're going to talk about is periods. What are periods? Periods are small instance of ranges for the date time. So periods range from seconds, minutes, and hours. Don't do anything beyond that for period because it'll be confusing. So periods are for small intervals, right? Setting a period for, let us say, a period is for long intervals. A duration is for a short interval. So use periods for longer intervals and use duration for a short interval. Here we're looking at period. So what are we doing? We're trying to create a time period of 20 years and 10 days. One of the first things you'll notice is period offers you a static called period.0, which means there is no time elapsed from what you're trying to do. And that the new date time API allows you to perform mathematical operations on it. So you can do plus and minus, you can do plus days, plus hours, minus hours, etc. on the API itself. You don't have to write any special code for that. In the past, you had to use a calendar, increment the value of a certain field, and then recreate a date from it. You don't have to do that here. You can create a period. For example, here, the to-do says replace the period.0 to a time period of 20 years and 10 days. And we'll do that in a minute. First, I want you to run this code and verify that it fails. And it should definitely fail because we have not done any change and there's a to-do here that we need to fix. So let's go fix this code. So what does it say in a hint? It says there is a period.off and you could pass it some value. So let's check that out. So instead of a 0, let's do an .off. And in here, I could pass it the number of years. So my number of years is 20. My number of months is 0. And my number of days is 10. So we created a time period of 20 years and 10 days by supplying it 20, 0, 10. So this code should now work. Great. So now I can verify that my 20-year, 10-day period has 20 years in it and has 10 days in it. And that is 2 of the assertions we looked at. If we were to run this code now, this test should pass or not. Let's see. Now, we've since passed that test, but now it says there is something else that is a problem. Okay, so we have other tests that are failing in the same code. And what does this other test look like? Here I'm using a clock. I created a local time with a clock of the terminator original judgment day, which we set as 1997 August 29th, 2:14 a.m. Eastern time. Now, The to-do says create a method to create a time period using this 20 years, 10 days on it. So the calculated time 20 years and 10 days later from the original date. And we pass it the original date, so obviously it's going to fail because it's still going to show you 1997. What do we do? So here we need to use the plus API, which takes any temporal amount. A range is a temporal amount. So let's try that. We created a time period, so we're going to do a plus. And the temporal amount we have is what? What did we call it? 20 years and 10 days. So let's use that. Okay, so now I have a terminated original judgment date time plus 20 years and 10 days. And now my date time should have a year of 2017, which is 20 years later. And instead of it being August 29th, it should have September 8th. And that's what we're trying to prove here. So let's run this test again and make sure that everything passes now. And great, now we have seen how periods work. We see a period of 20 years and 10 days, how I can create it, verify that it has the right values, and then how I can use it against the time that I created using a clock or otherwise, right? It just requires an API that uses a plus or a minus, etc., and you can use these APIs. Now this test is going to fail, but I'm going to show you that there exists a minus, and you can do minus days, minus years, hours, minus minutes, etc. So you have a lot of possibilities. And what is the most awesome is you actually have minus weeks that could possibly never exist in the calendar API. So you could actually subtract weeks from a given time period and get to another time period a few weeks ago. Or you could do plus for the same as well. So that's something I want you to remember. The newer API is more fluent and more humane. So using the newer API helps you write better code. That's something I want you to take away from this. Now, creating a period using fluent methods. In this method, in the past one, we saw we created a period of and we passed it 3 variables. That doesn't look very fluent because it looks pretty clunky if you ask me. There is a better way to do it. And this better way, what are we doing here is we are creating the same time period, but instead of using an off, I am actually going to use an off years and with days method. So let's see how it looks like. So I don't have to specify the months at all because I don't need it. So instead of off, I can do off years and I pass it 20. And I can use Fluent API and say with days and 10. I never mention months. And this is much more readable. I can see that this is 20 and 10. I don't need to understand why there was a 0 here to begin with. What are my tests? My tests are exactly the same. I'm doing 20 and 10. So these 2 tests should pass. And I have another test where I'm getting a clock-based local date time. And I am still setting it to the same. So I can still do a plus here. And I could still pass the temporal 20-year, 10 days time period. And my test should pass exactly the way they did before. Let's run this code. So what have we taken away from this API is that I have the ability to create periods. I have the ability to do mathematics on my new containers. So Java 8 plus time API is actually pretty fluent and useful. It's readable as well. Now the same goes for durations. So let's quickly take a look at durations, right? So here I'm creating a duration of 3 hours and 6 seconds. Periods are for long intervals, durations are for smaller intervals. So remember that. I made a mistake when I first started talking in this kata, but periods are for longer durations and, well, I said it, periods are for longer durations. So here we have a duration of 0, and I'm trying to convert it into a different format. The way you can do this is by using chrono units. Chrono units are time units or temporal units that exist. So if you were to do a duration.off, your API will show you something very interesting, right? So let's take a quick look at the duration.off API. It takes a long amount and it takes what is called a temporal unit. I don't know what a temporal unit is. It is an interface. So let's go take a look. This interface doesn't give me any constants. I can't use this, but it definitely has a child, and one of the child interfaces it has, an enumeration is a chrono unit. And the chrono unit gives me signatures such as nanos, micros, millis, seconds, etc. I can use. Great. Now that I know this, let's go leverage that. So how do I do this? I have a chrono unit. I know it is 3 hours and 6 seconds, but I can only pass it 1 chrono unit. So I'm going to convert the 3 hours into seconds. So it is 1,800 seconds plus the 6 seconds that I already needed for the 3 hours and 6 seconds makes it 1,806 seconds total. So if I were to pass it a 10806L, which is long, and my chrono unit of seconds, I believe I've achieved what I wanted to. I got a 3 hour 6 second time period. It's a duration. And I'm asserting that the number of hours in this duration is 3, which is what we wanted. And the total number of seconds is 10806, which is what we set. So we should verify this. Let's run this code and verify that these work. Now this test is going to fail because of something else, is that we did not do the second part of it. But the first one passed, and we'll take a look at why this failed. Here I have a calculated 3 hours and 6 seconds after my terminator judgment day time period. Once again, I can use the plus API here, and I can pass it the duration we created, which is 3 hours and 6 seconds. And now I can verify that it should be 5 a.m. It should be 5:14 a.m. and it should be 6 seconds after the 30-second time period. It was 2 hours, 14 minutes, and 2 a.m., 14 minutes, 30 seconds, and this should be 36 seconds. Let's run this test. And boom, we got this working. So we now saw how durations can work. You saw that periods and durations just need to be set up with values, and you can use them. Now, it was very confusing to do that using that conversion of converting 3 hours into seconds, creating a single chrono unit. Who's going to remember all that? Obviously, there is more fluent API that you could use. While that is very flexible and useful, you have a better API. Let's look at a better API. So instead of doing that, I could simply pass it of hours 3 dot plus seconds 6. Much more readable. But I've achieved the same thing. I've created a duration of 3 hours and 6 seconds without having to do that mathematics of converting hours into seconds, adding the seconds, and then creating a chrono unit based duration. Here I've just used fluent APIs. So if I were to run these two tests, they will pass, but my other two tests will fail because I've not yet converted. So let's quickly do a plus and pass in the 3 hours and 6 seconds. Now this entire test should pass. Let's run this, verify that this code works, and we're golden. Awesome. Any questions before I move on to time partials?
Yes, there's a few questions. Sharisa is asking, do daylight saving times have any impact on how on the use of these APIs?
Yeah, so in fact, they don't, which is one of the things that I've been trying to stress on. Thank you for the question, Sirisha, is that what you're doing here is you're setting a fixed clock. Once you set a fixed clock, you don't have to worry about any time changes, be it you changing time zones or there being a daylight savings versus non-daylight saving. So when I run this test today versus when I run it in December, the output should exactly be the same. I should, as a developer, I should not be worried about what time zone this test is being run in. And that's how every single test should look like. So a clock-based testing mechanism is something that will always serve you, irrespective of whether you move time zones or whether there is a shift in daylight savings versus not. So that is something I want you to take away and use clocks as much as possible. I don't know if that answered your question.
And then Neha, you kind of already went into this. I was asking what is the chrono unit for, but she kind of asked that before. You kind of just gave the in-depth explanation of what chrono unit was over the past couple of minutes. So right. I think that is it. Yep.
Great. Thank you. Thank you for the questions. Those were good questions. All right. Very quickly, let's go into the partials. We saw ranges. We saw containers. We saw ranges, which is duration and period. And now let's take a look at partials. Partials is portions of a date or time. So here we have, once again, a clock. And we're going to look at month, day, year, month, and day of the week. These are extremely repetitive. So I'm going to do 2 of them. And you can as well blindly go in and just make that one change every single method and they will work. I promise you that. But first, we again create our Terminator original judgment day clock. It's a fixed clock. So it'll always run the same no matter where you are in the world, what month of the year it is. It'll be always the same. How are we going to verify this? The first test is to verify the month of the judgment day. Obviously, this is not going to work because we're in October. So when I do a local time of now without a clock, it'll fail. Here, what did I do? For some reason, I think I've already solved this for you. It actually works because it says get month, and this should directly pass. I don't have to do anything here, and boom. Looks like I solved this code for you already. Looks like I solved all these methods for you. So it's not much to look at, but it is quite simple. What am I doing here? I've created a local time, passed it a clock, and this should have been null. For some reason, I solved it and probably committed the code. But I've just proven that you can get the month from the local date time and extract just the month component of it. The same goes for verifying month and day. This is something you use for a birthday, for example. You don't want to specify how old you are. So you usually just give people a day of birth and a month of birth, right? And that's what we do by creating a month day dot now from the clock, which means I should be able to get August 29th without the year. So if I wanted to set a reminder every year, I could just create a month day and say, hey, Monday, remind me when it is August 29th. And that's how I can do this. Right. So monthday.now takes a clock, month.now takes a clock, local date time.now takes a clock, year.now takes a clock. Actually, month does not take a clock. You first create a local date time and then get the month from it. And the reason is, or you create a local date and take the month from it. The reason is month is an enumeration. It does not have a now method because you can't create an instance of a month that way, right? Year has the exact same logic. You could do a year.now from the clock and therefore get the right value. And we can just prove this real quick that we should be able to print 2020 here. So year.this year. Okay, so we created a year.now. And if I were to system out printer in this year, let's go run this code real quick. You'll notice that this year is 2020. And that's how a year API works, right? So you can create today's year, or you could create the year from your fixed clock. Both work. And I just want you to take away that using now and now with a clock have very different means of working. If you use a system clock, they should be exactly the same. And we can also prove that real quick. So if I were to change this to, let us say, clock.system default time zone. Now, if I were to run this, this will obviously fail because it's 2020, and let's verify that it fails. Great. So the year actual is 2020 when it should have been 1997. So this is one way for you to understand how partials work. You can have month, month, day, year, month, which is very useful for credit card expiration, for example. In this case, I guess I did not solve it for you. But if you were to just put terminator judgment day here, this code will work because you're getting the year and month, but you're not getting a date associated with it. So if someone asks, what time frame roughly did this happen? It happened in August of 1997. Boom, there you have it. You can do that. When does your credit card expire? You don't have a specific date. You have a month and a year. That's what you use for that. So there are partials that you can create with the new API, which was not easy and convenient with the older API. What we used to do with the older API was to create a date and use some sort of a simple date formatter that just had YYMM in it. And that's how we would end up showing you year and month. Newer API gives you an actual object that you can do mathematics on. This has methods on it. So understand that when you use year month, you actually get mathematical API on it. You can calculate plus minus on it, right? So it's extremely powerful, it's extremely strong, and it's extremely humane. And that's something I want you to take away. Give me a second while I get some water.
I guess real quick. So we have a question. So the question is, we no longer need to use Delta time, and all daylight savings time issues are fixed with the Java 8 plus Java.time library, correct?
Correct. I would actually say that with a very strong sense of belief that there is no more a need for you to use an additional library to leverage the features of what Java offers. Now, while that is true a statement, and that is to the best of my belief, there are still some things available in Joda time that are not yet possible with the Java 8 time library, right? So there is something called 310 extras. It's a library. It has more features available to it that are not yet there in the Java 8 time library. So you may need to depend on it for that. Things include ranges. There are other durational aspects. I cannot recollect the exact nature of everything, but I can get you a resource where you can get more information on that.
Yeah, I do also remember around the release of Java 8, like even the authors of the Java Times said that they would generally recommend, I guess, except for those cases you named, of using the Java 8 library, not bringing in Java Time anymore.
Correct. And definitely there are a few changes from the Java time library to the Java 8 time library in terms of the interfacing, etc. One of the links included in the PDF that if you check out the code, you'll also get the PDF, is basically how they are organized in the hierarchy of the different containers. That has undergone a change. Chronology has undergone a change compared to Java time. So there are some differences in Java 8 time from the Java time. So it's not a 1:1 parity. But if you were relying on features that Java time 310 API, 310 extras provided, those don't exist. That's why they're called 310 extras, right? And those were written under the Java umbrella rather than put into the Java 8 API. Just wanted you to know this. Great. So here's the last test, and this is probably, we're out of time. Should we go into the last test, or Billy, what do you want to do?
If it's just a couple more minutes, it's fine.
Okay.
But yeah, we are kind of getting a little bit longer. Want to probably wrap it up here pretty soon so people can get to dinner and everything.
All right, understood. So I'll just walk you through the code base here. I'm not going to attempt to solve this. But this test goes into using datetime APIs and streams. So not only can you use the datetime API in mathematics in regular code, you can also use them within stream code, right? So here we have, let us say, the ability to add days, subtract days. And we've done this before. But you can also do the same thing within a stream. And you, for instance, over here, I am creating the next or same Sunday as a temporal. One of the most important things that you will find yourself doing when you do mathematical calculations on the new API is use temporal adjuster. This is an awesome, awesome tool, okay? A temporal adjuster allows you to manipulate or calculate different values from a given date, right? There is a utility class called temporal adjusters. And this class is something that I want you to take a look at. These two classes are probably or what I would refer to as sledgehammers in the new API. So give me a second while I bring this class up, and I want you to take a look at its API. So what can you do here? You can get the first day of the month, last day of the month, first day of next month, first day of the year, last day of the year. These were things that were never available with the older API, and you had to actually juggle through some hoops in order to get calendar to get you these values, right? And from there, you could not actually get, let us say, the day of the week for the given date. You had to do other arithmetic on that. All that is made available for you using temporal adjusters. These are normally and frequently used manipulations on a given date. What was the first date in the month in which I'm currently in? Boom, you can get that value. From there, you can actually get the day of the week. What was the last month in the day for a given day of the week? What was the last Friday of the month? You can do things like that. What is the day of the week in the month for a given ordinal? These are like extremely useful and rich APIs that are provided in temporal adjusters, and these can also be used within the construct of a stream. So if you have a list of dates, or let's say a collection of dates, you can apply some things to it. For instance, in this case, I am applying the next or same Sunday value to a list of dates, and all I have to do is transform this to take the next or same Sunday from here, right? So I could do a temporal adjuster on this, and lo and behold, I can create a list of Sundays for the given dates that I have. And this way I can find out a list of Sundays from any date, right? And these are things that are extremely useful, and these are manipulations you probably do quite frequently. The last one that I wanted to highlight is getting a 2 business day shipping calendar. You're building some sort of a program that has a cart associated with it, and when someone places an order, orders are delivered in 2 business days. Now, if it's a Monday, Tuesday, or Wednesday, it ships 2 business days later, which is 2 physical days later. But if it's on a Thursday or a Friday, you have different shipment dates, right? A Thursday goes to a Monday, a Friday, Saturday, and Sunday ship on a Tuesday. And how do you build this logic? You use temporal adjusters, and you do some amount of mathematics on the current date, week of the day, and you can get its ordinal value since it's an enumeration. And based upon that enumeration, you can calculate if it's equal to 4, it's a Thursday, so you ship on the next Tuesday. If it's 4 or above, if it's 5 or above, you actually ship it on a Tuesday. And that logic is basically zero-based ordinal. So you go back to your regularly scheduled programming practices of zero-based ordinals when you use day of the week as numbers. So that's where I want to end this. Thank you for your time. Hope this was useful. Please do check out the code and let me know if you have any questions. And Kendrick, you had a question. If you still want to reach out, I'm available on Twitter.
Thanks for this great presentation, Chandra. In my before became a developer advocate, I worked at I was consulting at a shipping company here in Kansas City, actually YRC, who is one of our sponsors. And I distinctly remember really feeling the pain of running into date issues. That was very frustrating. And at the time kind of changed over to having to use some Jota time and maybe some Java 8 time, but it was my first real experience of just the particular pain that comes with daytime. It's one of those, once you run into it, it's brutal. So, I definitely know if I ever have to do some more stuff with date and time and stuff like the end, I know where to go to get a lot of my answers.
Great. Thank you so much. I hope there was actually no interaction. Otherwise, I would have, gauged what the audience wants to know. But if there are any questions, please feel free to reach out. I look forward to hearing from you. Any suggestions or comments are also welcome.
Yeah,
thank you.
It looks like no more questions since then. But yeah, definitely, like I said, reach out. We'll let us know. We'll pass along any questions you might have. And thank you again so much. And thanks for kind of luckily coming out to have our October meetup. So thanks again.
My pleasure. Thank you so much for hosting me.
All right. Thank you.
Thank you.
See you.
Bye-bye.